Hello everyone and welcome back to the continuation of our industrial warehouse modeling series in which we are going to be continuing the modeling efforts of that warehouse. And please notice that this video is part of a video series that goes in tandem, in which you have theoretical videos as well as modeling videos. Of course, I'm gonna pin a link for the playlist on the top right, so check this out if you are new to the channel. With that being said, in today's video, I'm gonna model me a crane, and also I might make my columns a little bit longer and model a gable frame and as well as loads. So sit back, relax, and enjoy the show. Okay, so let's continue our efforts now. Now, first things first, while I was doing this crane runway, as you remember correctly, while I was doing this crane runway, I realized that the distance here was 5.75 or something. It was kind of odd, so I thought, hey, I should increase the height of this by 1 meter. So is there a quick way to do that? The answer is yes, and I will show you very quickly how you can do this. First of all, I'm gonna shift this as a copy because I will deal with the copy now. So I copied this on the side here, and how could I basically make the columns longer? Now to make the columns longer, and this is something that you might really need in your modeling. Like you mess something up and you realize, hey, I need to make my columns longer. Of course, the first option is to destroy everything and try again, which is kind of not really the thing that I want. But let's say that I want to increase the columns by 2 meters. So how would I do that? Now, first of all, I would select everything like this and go to Edit, Move or Copy, and basically move it up 2 meters. So 0, 0, 2. I'm setting it up. I will not move, I will not copy, I will move. So let's execute this. Now it's 2 meters longer. I think so far, so good. Unfortunately, I don't have access here. I mean, I could deal with this, it's much easier for me. But I don't have access here, so let me create some access here to deal with that thing. Let's just add some access here just because I need to deal with this. Okay, I think we're doing great so far. Okay, now I'm gonna basically do some AutoCAD tricks to do this. So I'll just go to Geometry, Members, and draw me some members here. So I'll just basically, now this is only a line for purposes I will explain in a moment. So here is one line here, and here is another line here. This has no meaning at all. It only serves a purpose that you will get very clear in the moment. So you have 2 lines here, okay? I think so far we are doing good. Now I will go to Edit and go to, where is it? Extend, exactly. I'll extend my columns, and first of all, he wants me to select the boundary edge. The boundary edge is this. That's my boundary edge. And now I'm gonna extend me the columns. So you click like this, and now your columns get extended. So now I'm increasing the length of the column artificially. This is like kind of next level stuff I'm doing. I've never thought I would do this, to be honest. But well, wait, will it work? I don't think so, right? No, it doesn't work, okay. So I never thought I would need this technique. I once was discussing with a friend of mine, like when I was a junior engineer, we had discussed some hypothetical, like me and my friend, we like to do those brainiac stuff. So we thought, hey, what would you do if this hypothetical situation happened to you? And I thought, hey, I'm gonna use AutoCAD. I'm gonna draw me a member and basically extend to it. And well, turns out today is the day where I would be needing this technique. And okay, now I've extended my columns. Of course, that's not enough. I might keep this, I like it, but I will just deal with this now. I just extended my columns. I don't know, to be honest. Now there is a problem still, because if you open the supports, you can see, wait. Now some supports got extended, some of them didn't. Okay, because there is like this, this bracing. Okay, so let me just go here, select those and unsupport them. So support, delete. And I'm gonna select those and unsupport them. So let's take a look how it looks now. Fantastico. Are we finished? Of course not. We are not finished. I have to take the bracing. Oh my. I have to take the bracing and pull it down. Was it the case? Yeah, it was the case. Okay, fine. I mean, why not? All for the viewers, right? So I'll click here, drag it with me, and just throw it here. So that's the bracing number 1. And then I click this, 1 click. And look, how do you drag something like this? You click on the element 1 time, you move your mouse away, you click on the start of the element again, and now you have it in your hand. And you click here. Also, like this should be in the tips and tricks video, right? Also here, So yeah, we made our longer columns. Of course, there is still the cladding to be done and the purlin to be done here, but this I will leave for you. I only wanted to, our dear member Donald Khani was talking about the problem of having uh, longer columns, which would need some buckling stuffs to be taken into account. And I've done that because, well, I want to address his issue. So I will leave it here just because I want to mention how this is done. Will this have consequences on the design? Yes, it will. Will I address them? Maybe. I will leave it here. Maybe I come back to it later or not. I will be continuing on my main hanger, which is this guy. This is just for a small little idea I wanted to mention here. So now we are back here, and on my to-do list, I have my crane, my loads, and my gable frame. So okay, let's go to our crane first. Now, I need to open Paint for this. Now, I'm lacking crane information, to be honest, but I only want to tell you that the crane is basically a girder or a beam that moves on two runways, and I've explained this before. There is a video that I will link above about the crane. I have a girder, but I'm going to be a little fast today. I have a girder that moves on a runway, and there is a crane here. Let's say that the capacity of the crane is, I don't know, 10 tons, for example. So if you have 10 tons tension, which means 100 kilonewtons, now the 100 kilonewtons will cause reactions on the runways. Of course, the reactions on the runway depend on, by the way, I'm saying 100 kilonewtons, taking into account any dynamics here. I do not have any values. So, and also, even if I have values, it will not help me because each crane manufacturer on his own, right? Also, as far as I know, the crane manufacturer is responsible for basically having the runways and having the girders and designing them, I think. Also, as far as I know, I mean, from one project I was involved in, what happens is that the person or the company that is going to come and install the girder will ask you about specifications for the columns as well as this little extension that you put on a column to put a runway on it. Like those are also being controlled by our crane manufacturer. So sometimes the crane manufacturer tells you, hey, I want your columns to be at least IPE so-and-so, and for this to be at least so-and-so long and so-and-so strong. I don't have those because even if I have them, it will not help you. So I'll just tell you, hey, keep in mind that during the modeling and planning process, you will have to know what your crane is. You will already have to know your supplier for the crane, and you have to call him and go and meet with the guy and tell him, hey, what are your requirements here? What is the clear height above the girder? What is the clear height below the crane girder? What are the loads to be expected? Are there any extra things you want to keep into consideration? However, I do not have those things, and even if I have them right now, it will not help you because it depends from one supplier to the other. The only thing I want to say is that I'm going to basically apply me a 100 kilonewton load on the structure that moves. But wait, now the 100 kilonewton here, as you know, if you have a beam, and you have a 100 kilonewton tension force, the reactions on the beam depend on the position of your crane. Like if you move it to the right, the reaction here gets bigger, or larger. If you move it to the left, then the reaction here gets larger. So how am I going to do that? You see, I'm going to assume that I have two maximum cases. That's an assumption, of course. It's not my responsibility to assume those things. You should go to the supplier. But for the lack of better options, I'm going to assume that the maximum reaction I can get here is 90 kilonewtons, and here 10, and vice versa. Why? Because you cannot just put the crane above the runway exactly because there is no space. There is always a minimum spacing between the crane and the edge of the runway. So I'm assuming like the maximum reaction you can get is 90 kilonewtons and 10, or vice versa, like 10 and 90. So I would basically assume both to be 90s on my structure. Once again, that is what makes sense to me, but in reality, you have to talk to the supplier and basically hear him out. So for my structure here, I'm going to assume that the crane is moving in parallel on the runways and has a force of 90 kilonewtons. How do I do that? Well, I need to go to load, and I have a video for this. So I'll go to load and go to special loads. There is something called moving load. And now I need to basically define me a point load. Now, the case for the load here is going to be called crane loads, okay? And just saying something else here, that the crane load not only has a reaction, not only does the crane have a reaction here, 90 and 10, it also, like if you have a crane like this, there is a variable case in the reaction, and there is a static case in the reaction. The static case in the reaction is basically the self-weight over 2. So I'm assuming here that, for example, my crane is, I don't know, like 90 kilonewton load and 10 kilonewton statics or something. So what I'm saying is you should take this into account. Okay, there's something I missed very quickly. I want to repeat the crane thing. So if you have a crane girder with a crane on top of it, there is of course the dynamic part which moves, which is the 100 kilonewtons, and there is the static part which is the weight of the girder assembly. And please notice that this moving part will have a variable reaction, and we said that we're going to use 90 kilonewtons because we're not going to be able to put this on top of the girder, which means 90 kilonewtons moving, but wait. There is also a self-weight of the assembly. I'll assume 100 kilonewtons being on the reaction, not because the load is 100. No, the load is actually 100 kilonewtons moving plus 10 kilonewtons from self-weight. So I'm actually taking 100 out of 110. I hope this makes sense. Okay, so crane loads, I'll just basically go to the PL here. I want to do this as my crane load, and I will click to check out the value, F equals 1. Wait, what? Shouldn't be 1,000? Okay, let's take a look. Length in meter, force in kilonewton. Okay, I want 100 kilonewtons, so here is your 100, enter. According to him, he's telling me that the units are length in meter and force in kilonewtons, so I want 100 kilonewtons. I'll just say here, I don't know, I'll just add this, I guess. Okay, fine, I'll modify PL. And now it's 100 kilonewtons. It moves from here to, I need to be able to click it, so here. Okay, I have it now, close, that's 1. And that's crane load left, I guess. Of course, I can make a step size here for 1 meters. Load direction is 0, 0, -1, -1 in the Z. And yeah, I think we are doing great so far. So I'll just basically apply this. And now I will say crane load right. Another one. And here it's gonna be walking or moving. I can't see anything now. It's gonna be moving from, define line from here to the end. There we go. 130 and 30, close. I'll apply now. So now I should have 2 moving loads for the cranes. So crane load left, and you can see this getting highlighted, and crane load right, and you can see the other one being highlighted. Perfect. Of course, notice that I made sure that both loads move in parallel. Yeah, I think this makes sense. I'm just a little bit angry, or not angry, I'm a little bit worried, because when you design, he might think to put the crane load on one point on the right and another point on the left. But no, I don't think so. The most critical design would happen if both crane loads are in the same place, because they would affect both the same portal frame. Yeah, I think that's not a problem. I was just worried a little bit. Okay, so now we have our crane load. What else remains? Well, the own weight I need to add, because I remember in one of those technicalities I removed the own weight. Did I? What is this? What are those loads? Okay, those. Oh, right. I remember. Those are the loads we tried during our trial error thing, during our cladding dilemma, right? So I go to member. I'll add self-weight. I'll add self-weight for the entire structure. So now everything has self-weight. Perfect. And now we need to apply dead loads. Of course, here dead loads depend on the requirements of the client, but so I remember I've explained this before somehow, like there was like something about the dead loads. Let me just quickly check. There we go. Yeah, there we go. So those are the dead loads, the superimposed dead loads, as some people call it. And there is like steel roof sheeting, aluminum roof sheeting, insulation, and so on. I think I'll go with steel decking, I guess. He also takes steel purlins distributed over roof area, but nobody wants about this because I have my purlins already taken into account. So let's take a look. I'm gonna take the max here, which is 0.2. That's steel decking, and I want to add to it insulation, I guess, but not glass fiber. I want to add insulation boards, 25 millimeter thickness. Let's say we have 50 millimeter thickness insulation, 5 centimeters meaning. So this means that my total superimposed dead load would be 0.2 for the steel decking. I'm assuming an assumption here for the cladding load, but of course, is it correct or not? It depends on what you have in your current in your local basic local region. I don't have it, so I have to use the codes and stuff from references. So I will use superimposed dead load of zero point 0.2 in addition to the insulation, which is going to be like 0.07 multiplied by 2. So 0.34, that's my dead load. But wait, we're not finished because there is like the overhead lighting and piping and AC and cables. And according to the reference number 1, which is the Steel Design Portal Frames Euro code, it's between this and this. It's a big range, to be honest. I don't know, okay, so I don't know. I just assume it to be 0.3, I guess. Like it's between 0.15 and 0.4, so 0.3 should be variable. So my dead load is 0.64 kilonewtons per meter square. I'm surprised it's that small, to be honest. I'm really thinking it should be more. I'm doing everything as the reference says, but to be honest, I just have a bad feeling about this. Like less than 1 kilonewton dead load. That's what are we? What are we doing here? Okay, am I missing something? Dead self weight is there. Cladding, as you can see here, there's typical weights. We are dealing with AC and piping. I don't like that. You know what? I'll just say superimpose dead load 1 kilonewton because I'm kind of worried. Like 100 kilograms per meter square should be golden. So 1 kilonewton per meter square. That's my dead load. It should be 0.64, but I will take 1 kilonewton because why not? We do this actually. Like I know you would think, oh wait, he is being too conservative, but I think we have done this all and we all have done this in one part of our lives. What about the manlast or the basically live load? Now it's a inclined roof, you will not have peoples, but at least for the live load, we can see for alpha less than 30 degrees, your live load is 0.6. Yeah, I mean, take a look. I mean, dead load should be a little bit more than live load, right? Like, should be. So, okay, I think I have my loads. If you're new to this channel and thinking, whoa, I have never seen this presentation before, I will put a link to the lecture here in which I was discussing the loads. So I told you this is like a tandem video series. Okay, so back to our point here. I put my pen away. And okay, we want to put our loads here. So dead load was 1 kilonewton per meter square. I'll go to loads and go to, what am I doing? I go to load here and go to surface load. My dead load is 1 kilonewton per meter square. So in the global negative 1, I'll add that. And now I need to add it to the claddings in the top. You can go to front like this, click here, select that, and voila, I think we're done. Are we done? Yes, we are. Why is the scale so bad? Am I missing something? I think I'm missing something. The scale is tiny. Why? What do I see here? Wait, are there two forces? No, that's dead load. Okay, I'll just leave it. Okay, so let's go to live load. I'll go to load, or basically load types. I'll add me a live load. And well, it's called live load 3. Why? I think during our work on this, we have to find multiple live loads before, I guess. Oh wait, no. The idea why live load 3 is called is because he assumes crane loads to be nature of live, which makes sense. Talk about the category later, because I have a comment on one of our subscribers who was asking me about combinations, automatic and manual, and I think I'll be talking about the combinations in the next video, because today I will only try to apply the loads, and maybe do our gable frame. That will be more than enough. Okay, so I'll leave category A for now. I'll talk about different categories of live loads later. Of course, those of you familiar would immediately know what category A is and why we should change it or not. So I'll talk about this another time. Anyway, I'll go to my live load. I'll select me a surface load. I select a live load of 0.6 because reference. And in front, I'll just select that and end that. So apply. See, now the live load is large. And why is dead load small? That's a crane load. See, that's what's bugging me. Look, the dead load is small and the live load is large. Now, what about wind loads? I will not have snow loads here, but what about wind loads? Wind loads are kind of special. I want to talk about how to define wind loads later. I have a nice trick up my sleeve because robot is really abysmally weak in wind loads, but I can use the weakness of wind load in robot to try to define my wind loads. So the lateral loads are not yet defined here. I will have to define me wind loads and apply them on that warehouse. Also, I need to define the equivalent horizontal forces for the geometrical imperfections, and we have talked about this in our videos, loads. Yeah, so basically that's the one. If you go here, you can see like 0.3% of vertical. What you should be doing, I will just basically run the analysis and take the reaction at dead load here, multiply it by 0.3%, apply it on the top. Same thing for all the columns, and go to live load, take the reaction here, apply it on top, and so on. You get the idea, because I will have to multiply the vertical loading by 0.3% to get the equivalent horizontal force for the geometrical imperfections. Something I will be doing, I hope I don't forget, something I will be doing next time. But for now, I will do me the Gable frames. Now, how are those Gable frames modeled? I will assume now that, of course, I need architectural drawings. I'll assume that I have basically 1, 2, 3 gable columns and 2 gable beams, because I want, for example, to have a big opening here for a truck and a smaller opening here for my people. Of course, this is architectural stuff, and I will not be diving too deep into it. So, okay, let me just check. That's the 0. No, that's 15. Why? Where is my 0? Okay, so that's 15. And I want to add me 3 columns, so 30 over 3 is 10, which means I would need an x-axis in 10. No, that's incorrect. Wait, I want to add 3 columns, so I have 4 spaces. 30 divided by 4 is 7.5. So at 7.5, I want a column, and at 22.5, I want a column. So now I'll apply those. And now I have my 2 new x-axes. And here I'm going to apply me some gable columns. Okay, so how do I do that? Well, I go to column, and now I have to do another steel column. And now I'll create me another placeholder column, because my gables will be having a different section than my portal frame columns. So I go to IPE section, and I'll select me any placeholder section. For example, 300. This is just a placeholder. And now I'll just add me that and close. Those will be for the gable frame. And now here's the moment of truth. I'll just click on down, I guess. Okay, I'll just select on the beginning here, and I cannot select anything. So if I click here, this should be working. 1. Yeah, that works. And 2. And wait, did I click correctly? I think yes, I did. And 3. Okay, so those are my 3 gable columns. Of course, you can see a problem immediately. You can see that the gable columns on those 2 parts are extending beyond our portal frame, which shouldn't make any sense. So I just go to edit, trim. And once again, use AutoCAD stuff. So select cutting edges. That's my cutting edge. Did I select it? Yes. And then select the member to trim. So there we go. And then I go to here, select this as my cutting edge. And basically select this to my object to be trimmed. I think I selected the node, right? Let me select object again. Come on. Okay, there we go. So I trimmed them. Now I need to add me some beams, gable frame beams. I go to beam. I'll still select my IPE 300, was it right? Was 300? Was it 300? I forgot. Right click. I forgot my section. Right click, properties. Property IPE 300. Yes, I do the same beam section. So that's a beam now. and I need some heights. Okay, I need a truck, right? Trucks are like usually they go through bridges of 5 meter height. So define a axis of 5. That's for the trucks, basically. Wait, what? No, I mean 5 position. And for humans, I'm gonna put me a door of I don't know, 2 meters is enough. I think 2 meters are enough, or 2.2 if I want. 2.2. I'll apply, and now I have both z axes ready for me to be using. So let's do that. I select my beam now, go here, make sure that I'm clicking the correct one. How do I know? While I'm moving my cursor, you can see the coordinates being reflected here. So I want at 5 meter height, so there we go, that's 1. And of course here, that's 2. That's my first beam. And the second beam is going to be at 2.2. There we go, that's 1. And that's 2. Okay. Now I have my frames here that can be used. Of course, this is a moment resisting frame. I'm assuming that this is a moment resisting frame, so I'm not going to brace it. However, this might need lateral bracing. Oh, I need to brace it, right? I have an idea. And follow me with this. It's going to be cool if it works. Wow. Okay. The idea is that I want those to be also, because they are going to be released. I will not connect them to the portal frames in their axial direction, but I still need to brace them, right? Okay. This is something I'll worry about later. Maybe I will leave them at least braced. I'm just thinking loudly, how can I brace those things? I need to think about it because this will be unstable. Allow me to explain. Okay, this is the most resisting frame, right? Now I will just release that thing. So I'll go to edit, geometry releases. Oh, I can see the instability already. I hope you see it too. I am banking on this being unstable around Rx. So let me say here and say axial release, or full release. I just fully release it at the end. So nothing is being transferred at the end. Okay, so I think my recording software just crashed, so I had to repeat something very quickly. So, all right. Basically, if we run the analysis now, what we have done is we have applied just because my recording software has crashed, we have applied the full release on the Gable frame, and I was expecting instabilities. And to continue talking about this, I just save here. I'll call this promised warehouses because I have multiple warehouses, and I promised I want to show you multiple ones because I promised you 3 warehouses, so you have 3 now. And now I want to focus on this warehouse. So I'll now first of all save this as another file. And now because I want to focus on talking about this warehouse, I will delete the rest because I will upload the file where you have 3 houses here on the channel, of course. But now I want to focus on this because I want to discuss some instabilities that we have here. Now, first things first, I have instabilities because, why do I have instabilities? Because look how the Gable frame is connected. Of course, here this error is because there are no loads on the cladding, something we established last video. Now, the idea of the instability here is because this Gable frame is totally released from the portal frame. This is following one recommendation or one option that was recommended in the reference. Now, the reference didn't recommend a full release here. It recommended having an axial release here, but still benefiting from the resistance in the y and z directions as well as moments or something. So, or at least the resistance in x and y. Now, the problem here is I was thinking really hard, and you can see me doing some research here. I was thinking really hard, how can I make this? Like if you look at this, for example, like I did some research and I was like thinking and trying to find out how am I going to connect my Gable frame to the portal frame because you want it to be stable. And I think I saw that those Gable frames are just, not carrying the portal frames as we have agreed upon. I still was thinking, okay, how can I do this in real life? And of course, for the people who are listening to me right now, if you have an idea of this, please tell me in the comments. I would really like to highlight your comment in the next video. But I was thinking, okay, what's your problem? My problem here is, now those discussions I'm doing here right now, the monologue I'm doing, and the dialogue I'm doing with you right now, dear viewer, is one of the things that the philosophy of this channel is, to be honest, like to spark your interest and to really think critically. Because what's the point of me just dishing out information that everything works fine without really thinking of the details of it? I mean, look, I could just remove the release and make everything working fine, but then if I remove the release, this has a consequence in real life. This has a consequence on the connection. Now, I could, of course, fix all the supports here. This would fix the problem, by the way. Like, you can fix it to fix it. And now the supports are fixed, and now you don't have any instability. So you think you're perfect. You think you are happy now, but I am unhappy. I know a fixed support here would help solving my stability issue, but I have a problem with the fixed support itself, because something that you should do, and I will not do it today, something that you should do is to provide purlins, and those purlins would have cladding, so the entire wind load blowing on the side is going to be resisted by the gable frame. Now the gable frame is not connected on top, which means you have a cantilever moment, basically like a negative moment here, that is resisted by the foundation itself. And I don't think there is a foundation that can resist this big area of wind load unless you really design it to be big enough. So I'm not a fan of fixing those. I'm not a fan of fixing those supports, to be honest. Like, I don't know if you have a foundation that can resist that. So I'll just basically go back to pin and think about stabilization again. The problems I have with stabilization, why am I thinking so hard? I'm thinking so hard because you have to stabilize in three major planes. You have to stabilize in the XZ plane, which is this plane, and the stabilization in this plane is easy. It's stable because you have frame action here. The frame action here stabilizes the frame, or you can even put some bracings here and then everything is fine. That's one thing. Plane is easy to be stabilized, but this is not the only plane. You have XY, and XY plane can be stabilized by connecting the purlins to... Actually, I have a thought here. No, it doesn't work. Connection-wise, it doesn't work. By connecting the purlins to this. And okay, this is XY. What about YZ, like this one? I still have a problem here. How can I stabilize this? You have two options. You either make a frame action between the column and something here, the purlin. No, that's impossible. So some of you told me that, well, actually, those bracings should be touching the column. That's fine, but I'm still unhappy because those bracings are connected to the portal frame section. So even if in the model they touch the gable frame column, and even if touching the gable frame column stabilizes it, in reality, those bracings do not touch the gable frame column, and they should not contribute to the stability of the gable frame column. So I'm kind of like stumped, to be honest. Now, I could just wing it and tell you, hey, you could, for example, provide here a bracing diagonally and fix everything, but I'm unhappy. So what did I do? Well, I went to my lovely reference, the steel construction info, because I want to check it out. And lo and behold, it turns out that the steel construction info, the ones who gave me those amazing references, says there are two options. And although they seem to be on the side of having the rafters having the gable frame not connect to the portal frame, it seems that the pictures from real life that they provide onto their website actually shows you a portal frame where the gable frame is carrying the portal frame. And you can see it from the difference in the cross-section. I mean, take a look. The portal frame is big and huge with a haunch, but the gable frame is small because you're just, carrying the entire gable frame on columns. So maybe I should do that. I think I will go back to connecting them. But wait, if I connect them, how would I deal with the portal frame? Now, this is here. Now here, there are multiple options. I can just basically put one continuous portal frame here, but then you would think, wait a minute, this makes the portal frame section smaller. You're right, and this will cause some issues with regard to practical considerations, because in practicality, the top surface of all the frame elements, portal or gable, the top surface should be exactly on the same plane, because you want to provide purlins So the height of the top surface of all the elements should be the same so that you can provide smooth purlins above them, because the purlins are above your portal frame sections. So you need to keep the top side on the same elevation so that the purlins can basically do their magic. Now, if you change the section here, this will change the height of the section, which means you need to pay extra attention in detailing to push the columns a little bit higher so that the sections still remain with top side in the same plane of the other portal frames. Or you could just not do that and get the best of both worlds, because I told you there are two options. Option one is to consider the gable frame not touching the portal frame, because this allows extension, so you can delete the gable frame in the future and extend the portal frame. Or the other option was to allow the gable frame to carry the portal frame, and then the portal frame gets smaller. Or in case you want a third option, here's my thoughts on that. If you want to have both worlds, you could allow full frame action with the gable and the portal frame and not reduce the cross section of the portal frame. Like, I know that if you allow full frame action between the gable and the portal, the moments on the portal frame become smaller, allowing smaller cross sections, as you can see here. But if you are really interested in future extensions, you can still leave the section the same size of the portal frame. And well, if you want to extend, you just remove the gable frames, and you don't need to redesign, because you have the portal frame already ready, right? Those are my thoughts on it, and I want to hear in the comments what you think about this. Like, first of all, do you like those discussions that I keep? I know I've been monologuing with myself for around 5 minutes or 10, I don't know, my editor will know actually. But I think those monologues are important for civil engineering, basically, your career. So I'll just go to geometry releases and I remove the releases now. This also means that I would have some issues with the connection here. But yeah, you know what? Maybe I'm thinking about the connection now, to be honest. Like, if I remove all releases, look, if I remove all releases, if I remove them all, okay, now this is rigidly connected to this, like you have a rigid connection between them, which means bolts and whatnot. But can I get away? Can I get away if I release it, but not fully pin? Can I get away if I pin it? Because look, a pinned connection between two steel elements is easier to achieve than a full rigid connection. So will I get away if I pin it? My gut feeling says yes. So, okay. Like, my gut feeling tells me I should get away with it, because if it wants to rotate, like, look, I am not afraid from rotating in the XZ plane or in the YZ plane, but I'm afraid of rotating around its own axis. But having a frame action here will prohibit it rotating around its own axis. So my gut feeling says yes if I double pin it. Wait, I don't need to double pin it. This is pin already. Oh my. Okay, wait, let me just delete it. I don't need to double pin it here because the bottom side is pinned already, right? So I can go pin fixed. And wait, what? I'm surprised the robot is still with me. I thought that robot will just, give up and tell me, hey, go find yourself another software to deal with. I'm torturing it half to death, to be honest. But, well, let's take a look. Wait, what is happening? Is it right? I think it's right. Okay, let's run the analysis now. I am expecting it to work, to be honest. Like, my gut feeling tells me it should be working. So, come on. Come on, I'm so tired. Yes! Finally! Oh my. Finally. Okay, I'm happy now. Yeah. It was a roller coaster, to be honest. Now, of course, I can cladding it, but I will not do it because I will always, I might cladding it at the very end when I'm finished with modeling, because I will always want to have access to the insides. I want to see that stuff. If I cladding it, becomes harder among all those purlins I will have to add here. It becomes harder to basically deal with it. So are we finished? It seems nice and cool. But we are not finished. No, far from it, for multiple reasons. First of all, this column is too long. And this is okay, but this column is too long, so I need bracings here. And you can see this even here. Look, bracing, 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 bracing. So this column is too high. So I'll just mimic and make me a bracing here. I'll go to bar, simple bars. So let's go to members. And I'll go to bracing. I think it was around 20, right? I think it was around 20. And okay, so beginning. I need to be careful where I click. So that's beginning to, okay, what's the height? I will brace just one brace because, I mean, this is just for like completionist feelings, you know? So I have braced here and I'm gonna brace here too. I need to make sure I am clicking the correct point. So that's one. To the middle point of the column. There we go. And one here. Perfect. And now I'm not finished because the top side bracing is incorrect. Also, I need to copy this to the other side. So let me do the copying first of all. So I click on front. I select that. I'll go to edit, edit, move or copy. I'll copy it without dragging, and my distance is gonna be, I can cheat, right? My distance is gonna be in the Y 40 meters. So 0, 0, will it work? I don't know, 40. I'll just execute this, hoping it works. Let's just check out very quickly. Wait, what happened? Where is it? Oh, I'm a noob, right? I see what happened. I did the 40 in the z-axis. So, you know what? I give up. Here, it's like funny. The entire Gable frame is what is flying in the air. It's a UFO, right? Edit, edit, move or copy. And this time I'll do it by hand because I give up. So I need to be very careful where I click. I click on, because I have multiple points here, right? So I click here, and from here to here, and there we go. It should be correct now. Does it work? I don't know. Only one way to find out. So let's take a look. Yes, it works. Now, it seems everything is fine, and I'm happy now. Yeah, I can just start analyzing. I mean, I still have to do the wind loads and combinations, but I'm unhappy still. Why am I unhappy? Because the bracings here are not bracing the positions where the gable column is attached. Why is this relevant? This is relevant because those points are going to feel the force of the wind load. Like if you have wind load here, which is pressuring on this plane, if you have wind load here that puts pressure on this plane, you know how the wind load is going to be distributed. The entire gable frame will carry the wind load, and of course, it's touching basically the portal frame on top and the support on the bottom. Okay, so using paint now, this is a print screen. Using paint, you have pressures from wind attacking this side. I'm going to take this column as an example. And there is a portal frame which acts as a reaction to the wind load here. And of course, you have the support down here. Now, this reaction will cause pressure to be on the portal frame. This will lead it to bend in this direction and also to transfer the pressure or the compression force here through the purlin to the bracing. Like you see how much you are affecting the structure. So, I don't know, it's kind of, I'm not happy about this. I like to have bracings here. And it's not only me, it's also this construction info that basically you see the purlins, you see the gable frame being attached to bracings on their columns. So I think I should change that, and I will do that. Now, of course, we had a long time to do our bracings here. So how can I do this in the best way possible? I have an idea, and this is some unhinged thinking. And follow me with this. So what I'm going to do is, I'm going to run the analysis first, just to make sure things work. And things do work. Isolated node. Okay, that's not a thing I wanted to see. I have an idea. Select here, all, enter, and then delete. Delete. No, delete only selected members. Okay, run the analysis now. It should fix the problem. It does. I think that's happened when I edited and moved it up. I think upwards they were the nodes. So, okay, I've just finished the isolated node problem. And now everything seems to be fine. But now, see, that's the importance of intermediate calculations. Now I want to do some unhinged thinking. I will fix the problem in which you have the bracing at the gable frame column. So how do I do that? Well, I click here. Will it work? I'm not really sure. Let's click those. There we go. Is there a faster way of clicking this? I don't know. So I have those, right? Now what will happen is I will edit, move or copy. And I will move it this time. I have my arrow sensors are tingling now. I click from here. I'm really afraid of this. No, to here. Now I'm happy. This should work. Yes, come on. Okay. So far, so good. So far, so good. Yes. Will it work? Show me the node numbers. Yes, it's working. No double nodes. Okay, now I close this. Oh my, this is ninja style. I've never thought in my life I would need those techniques, to be honest. So I select the other ones. Don't mess up. Like, I never thought I would need those little techniques. It's like, like those are the most sacred secrets I have in modeling. I never thought I would have to use them. But well, let's do this. I'll click from here. Of course, it might not work, to be honest, but let's try it. So from here to here. Come on. I moved it, right? Okay. Let's take a look. Okay, everything seems to be right. It seems, but is it? It doesn't matter if it looks cool or not. What matters is it correct or not? So how do I know? Well, run the analysis. And let's take a look. Okay. So far, so good. I'm still waiting. Of course, this error is because there are no loads here. Right click, tables, not tables, what do I want by tables? I want to right click here, display, go to loads, load distribution regions, just to make sure everything is fine. And yes, of course, I'm not finished. This is still going to be the multi-parter, but you can see me how I would do things when I am really a junior engineer, like how I would do things if I'm tasked with such tasks. So of course, don't worry. This is an offset. So I would do it like this. I would ask questions. I would model. I would always think about the practical considerations, and always connect my structure with what I would do in real life. It's not enough. When you are a structural engineer and you're using softwares, it's not enough for your model to look cool. It might look cool, it might look amazing, but it has nothing to do with real life. What you must do as a structural engineer is when you model your structure, it's good to look cool, but most importantly, it's good to be practically relevant. And you have seen me thinking about this multiple times here. I know what you think. I think I messed up. You see me thinking about this multiple times, talking about how your analysis should correspond to reality. Yeah, see, I messed up. Did I release that? And it's not enough for you to look cool. It must be, I didn't release it. It must be corresponding to reality. For example, now I just forgot to release those bracings because I was hyper-focused on something else. So let's release that. There we go, pin. And I will analyze it next time, not today. So, okay. Now, what did I not do but should be done? What I have not do but should be done are purlins here and claddings. That should be done. I will not do it. And what I will do next time is I will talk about wind load and load combinations, and maybe start thinking about the design. So yeah, that's everything I wanted to talk about today. Before I finish, I want to give a huge CEE-sized shout out to our dear channel members whose names are going to be shown on the screen. I would like to thank each and every one of them for their contribution to the channel as they help me produce more of those videos. Also, of course, I want to thank all of you, dear viewers and subscribers. And speaking of which, I hope that you enjoyed the video and it was beneficial for you. If you have enjoyed the video, then please like, share, comment and subscribe, especially subscribing because it helps increase the reach of my channel. And also, maybe just suggest this to your colleagues. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video.